Example 4, writing a quadratic function. We're going to write the vertex form of the quadratic function, whose graph is a parabola with vertex at 1, 2, and passes through the point 3, negative 6. So we know that the vertex form is y equals a times x minus h squared plus k. So we need to identify important pieces. We know the vertex is 1, 2, so that is our hk. Then we know this point is just our x and y value on that vertex. On that parabola. So we're going to plug these in, and then we need to solve for a. So first I'll do the y equals a times x minus our h, which is 1 squared, plus our k value of 2. Then let's substitute our x and y values. So y is negative 6 equals a times 3 minus 1 squared plus 2. So let's simplify. Negative 6 equals a times 2 squared plus 2. Let's subtract 2 from both sides. We get negative 8 equals 4a, or a equals negative 2. So now we can write the final equation. Y equals negative 2 times x minus 1 squared plus 2. So go ahead and try the next example up here. Write the vertex form of the quadratic function whose graph is a parabola with vertex at negative 4, 11 and passes to the point negative 6, 15. Pause the video and I'll have the answer when you come back. If you tried this out, you would have gotten y equals x plus 4 squared plus 11. You would find out that a is 1. So we're going to find a minimum and maximum value. Consider the function f of x equals ax squared plus bx plus c. And this vertex equation here, remember this is how we used to find vertex, and we still can. So we're going to use this for our word problem. When a is greater than 0, f has a minimum at x equals negative b over 2a. So greater than 0, that means it's open up. So we see that that is a minimum value. And that minimum value we refer to as the y value, whatever that y value is of that vertex. So if we have a is less than 0, that means it's negative leading coefficient. We know it's open down, and therefore we know this is our maximum value. And again, it's that y value of that vertex. So let's try to find the maximum height of a baseball. The path of a baseball after being hit is modeled by f of x equals negative 0.0032x squared plus x plus 3, where f of x is the height of the baseball in feet and x is a horizontal distance from home plate in feet. We want to find the maximum height of the baseball. So we're going to use that negative b over 2a, whatever that value is, we're going to use it and plug it back into the function to find our y value, which happens to be our maximum height of the baseball. So let's go ahead and figure this out. We have negative 1 over 2 times negative 0.0032. And plug that in, you would get 156.25. So that is the x value of our vertex here. So now we're going to plug that into our entire equation. Negative 0.0032 times 156.25 squared plus 156.25 plus 3. So let's simplify that. When we do that, we would get negative 78.125 plus 156.25 plus 3. And then this would equal 81.125 feet. So that is our max height of the baseball. So I want you to go ahead and try this example. And you're going to rework example 5 when the path of the baseball is modeled by this equation here. Pause the video and I'll have the answer when you come back. So if you tried this out, you would have gotten that it was 39.7 feet is the max height of the baseball. The x value of that vertex was 71.43. Just make sure you apply the correct order of operations. Don't forget the negative in front. And hope this helps out. Thanks for watching.